power. What is power? Now, we need to define the power. As we know, this is the last thing. The work is equal to force multiplied by x. Now, if I ask you, any one of you, what if somebody asked us to move a couch from the first floor to the second floor, and I move it by 20 minutes, moving it, and one of you is stronger than me, move it by just during 5 seconds, 5 minutes, I'm sorry. So we have, this is me, and this is you. You are stronger than me. We have it for you. And we need to move it from the first floor to the second floor. I move it by 20 minutes. You move it by 5 minutes. The person who hired us, which one of us is the best for him? Is it me, the first one, or the second one? The second one, he don't need to stay 20 minutes waiting to lift anything from place to place. You need to do that fast. And also your car. Some cars has power horses more than the other cars, and they are much expensive. Why? Because, look why. Because why? Me and you, both of us did the same work. For example, if this mass is equal to 20 kilograms, I lift it from here to here, and I apply that weight force. So my force is equal to 200 newtons. Your force is equal to 200 newtons also. The distance in y is equal to 3 meters, for example. The work done is equal to 600 joules done by me and by you, the same. What is the difference? The work is the same between me and you. What is the difference? It is the time. Okay, what is the relation that connect the time with the work and make you better than me? It is what? The power. The power, simply, it is the time or the rate of work influence during that time. So the work divided by the time is equal to the power. So if we divide the work by time, we divide this over the time. The power is the work done during the time. If the time is short, for example, your time is 100 seconds. My time is 500 seconds. Okay, let us compute it. My power and your power. And you will see your power is higher. Okay, the work is 600. The power for me is equal to the work, which is 600, over my time, which is 500. It is 1.2 unit something. The power for you is equal to the watt, which is 600, over your time, which is 6 unit something. What is the unit of the power? The unit of the power, it is the unit of the watt, which is joule over second. This is the watt. The SI, or the international system, deals with the watt. But maybe you will deal with the power horse. I think it is 700 and something watts. I don't know how much it is. Okay, so my power is 1.2. Your power is 6. So you are better than me. Don't believe that. Okay, you are better than me in this thing. But I think I'm strong enough to do that, just like you. Okay, this is the power, which is the work divided by the time. What about force, position? This is the force. This is the change in position. So we have in our example, look here. We have the force is equal to 200 newtons. The change in x is y now is equal to 3 meters. F multiplied by x over t, as I did here. In physics, we are cheaters. Okay, we can use the time for the force. We can use the time for x, and well, that is what we will do. The time we will take it just for x. So f x over t. What is x over t? Who can tell me? This is the first relation I wrote it. I want. This is the velocity. Okay. Let us compute it now. The force 200. X 3 over the time. My time is 500. This will give us 1.2. Your force 200. Your distance is 3, but your time is 100. This will give you 6 watts. It's the same thing. Look, the time. And lift, when I do the work, it is the power. The force, no, not the force. The velocity of my force is the power. So I have it like this. At the end, the power. Next, we will use P for momentum. The power is equal to the time of the work. Also, it is equal to the velocity of the force. Velocity of the force or the time of the work. This is the power. Any question about power? We just solve an example. We define it. And the last page, page number 12, we have an example. And this example is solved. We just solve an example to know what is power. We can also talk about another example, and that's done for this chapter, which is the work and the kinetic energy and power. We have this system. We have a force pushing an object. The total distance L is equal to 4 meters. The force, this is the force, is equal to 200 newtons. Velocity, is it constant or not? We need to know that. The time lift is 10 seconds. Okay, what we need to know? Find the work to move the object from point A to point B. The distance, the work from A to B, it is the force. This is the force. and this is the distance. The angle between them is 0. The force is 200. The distance is 4. Cosine 0, which is 1. The force and the distance in the same direction. So it will be 800 joules. Okay. During the absolute age time, find the power. The power, it is equal to the work divided by the time. 800 over 10, which is 80 joules. 80 watts, I'm sorry. Okay. What is the velocity? I have the power is equal to the force multiplied by V. I know the force. I know the power. I need to find the velocity. The power is 80. The force is 20. Multiplied by 10, which is 200. Multiplied by velocity. The velocity is equal to how much? 80 over 20, it will be 4 over 10, which is 0.4 meter per second. Right? The kinetic energy. The kinetic energy, 1 over 2 m v squared. 1 over 2. The mass is, how much the mass? I don't know the mass. V squared, 0.4 squared. Who can tell me how can I find it? Without knowing the mass. We know from before that the work is equal to the change in kinetic energy. The velocity was 0 here. Then the velocity starts to change. So the work is equal to kinetic energy, to the change in kinetic energy, which is 800 joules. Without knowing the mass. Now I can find the mass. I didn't find the mass, but if you need to find it, find it.